The first salt, lithium nitrate, when you put it in water, will dissolve into lithium ions and nitrate ions. Neither of these ions, however, will react in water. I try to write out how lithium potentially could react with water to make lithium hydroxide, but the problem is that lithium hydroxide is a strong base. So even if it did make lithium hydroxide for a second, lithium hydroxide would just dissolve back into lithium. Nitrate ions likewise have a conjugate that's nitric acid, which is a strong substance. So there's no way that if you put nitrate ions in water, you will make this strong acid. So with lithium nitrate, since neither ion can hydrolyze, react in water, that no reaction will take place, so the pH should remain exactly the same as if it was in pure water, which would be 7. In the case of ammonium bromide, the ammonium ion, NH4, and bromine minus 1, when they're placed in water, ammonium will react with water to try to make ammonia and hydronium ions. Now, in the case of hydronium ions, ammonia is a weak base, so that makes this substance, NH4, some kind of a weak acid, which means that it will hydrolyze and reach an equilibrium. And the only weird thing is that when it reaches equilibrium, it will make some hydronium. And so you're increasing the amount of hydronium that's normally in water, so this will cause the pH to drop. In the case of Br minus in water, Br minus's conjugate is HBr. So therefore, since HBr is a strong acid, there's no chance that this reaction would take place. So nothing happens here. So when you put ammonium bromide in water, it should take the pH and actually drop it. In the case of the last salt, potassium fluoride, potassium ions, when they form from dissolving the salt, will try to react with water and make KOH. Unfortunately, KOH is a strong base, so this reaction will not go in the forward direction at all, actually go in the reverse direction, and so potassium ions will not hydrolyze in water at all. F minus will react in water to make HF and OH, and the reason I know that is because fluorine's conjugate happens to be HF, which is some kind of a weak acid, which means that F minus should be some kind of a weak base. And it doesn't really matter how strong or how weak it is, as long as it's not completely strong, this reaction will take place to some extent. It will reach equilibrium, so F minus ions will hydrolyze in water. They will create some hydroxide ions, which in turn will cause the pH to go up from 7. Now, how much it goes up from 7 depends on two things: what the concentration of F is, and also what the Kb value for F. But to answer the question, Kf will cause the pH to be greater than 7.